Good afternoon, class.
Good afternoon, Mr. Paris.
Welcome to today's class physics lesson. We need to continue from where we stopped last. In the last lesson, we had looked at rectilinear propagation of light and reflection at plane surfaces. We looked at certain terms such as light. What is light? Very good. Clap for Dennis. It is a form of energy that enables us to see. Very good. We also went ahead and looked at sources of light. We looked at two types of sources of light. What were the two types of sources of light we looked at? Yes, Hannah? Speak up, Hannah. Very good. Clap for Hannah. We looked at luminous sources and non-luminous sources. Examples of luminous sources we looked at. Yes, Ivy. The sun, very good, is a luminous source. An example of a non-luminous source we looked at? Yes, Francis. The candle. Is it a non-luminous source? Is the candle a non-luminous source? Yes. The candle is a luminous source, not a non-luminous source. Example of a non-luminous source we looked at. Somebody? Brian? The moon. Very good. The moon is an example of a non-luminous source. So what we have on the board there is an example of a luminous source. We also looked at other terms or concepts such as the light traveling in a straight line, where we looked at such an experiment on the board. We were able to conduct this experiment and we saw that light traveling from this lit candle is able to reach this person's eye. Yeah? However, when one of the boards is displaced sideways slightly, board C is displaced, this person is not able to see this light. What name did we call this property of light traveling in a straight line? Yes, Diana?
Rectilinear propagation of light.
Very good. Rectilinear propagation of light. Clap for Diana. We also looked at other terms such as array. What is array? What is array? Yes, Mary? Very good. The path along which light travels. So today's lesson, we want to explore further into the concept of light and look at what we refer to as shadow formation and factors affecting shadow formation. Now, shadow formation is a continuation of rectilinear property of light, as we shall see. It is proved that light indeed travels along a straight line. So into today's lesson, what is a shadow? Think, pair, and share. 1 minute. Yes. What is a shadow? Paul. Appreciate Paul. Paul is telling us that a shadow is formed when an opaque object blocks the path of light. Correct. But to understand further how shadow is formed and why we say a shadow occurs when an opaque object blocks the path of light, we are going to watch this simulation video. I'll be stopping the video at some point to ask you questions. As you watch the video, note down the important things that you learn from that video.
I'm good. What about you? Hey there, Meet Mr. Deer and Mr. Crow.
So, what do you think are those shadows cast on that screen? What are they? Where are they coming from? At that point, what can you see on that frame of that video? Anything you can notice that you can see? Yes, what is it? Yes, Grace. Very good. There is a source of light. Eh? Can we all see that? Yes. We have a source of light at that point. Anything else you can see? Anything else? Yes, John? An opaque object. Where is your opaque object? The hands of our professor here, isn't it? Yes. Very good. Anything else? What is this we are seeing here? Yes, Diana? The shadows of the hands of the professor. Eh? So why do you call this the shadow and not this? Why not the hands, but this? Yes, Hannah?
Because the hands are the opaque objects.
Yes. Very good. Clap for Hannah. The hands here are the opaque objects. Eh? What are they doing? They are blocking light from the source from reaching this area. And in other words, we say these hands are casting a shadow.
No, don't get confused. They are nothing but the shadow of my hands. Come, let me tell you more about shadows. Zoom in! Shadow is nothing but the light that cannot pass through an object. But hey, you can only see shadows of objects that are visible to eyes. For example, a tree will have a shadow, so will you and I. But not air and water.
So we have shadows of objects that we can see. Why? Why do we only have shadows of objects that we can see? Why do we have shadows of objects that we can see? Yes. Tieno. George.
Because the objects that we can see, they are opaque.
Very good. Clap for George. Any object that you can see is opaque. And therefore, an opaque object will block the path of light. Very good. In this other frame, we can see light passing through this object we are calling air. And do we see any shadow on the ground? Why? Why can't we have a shadow of air on the ground? Yes, Tasimio.
Because the air is transparent, hence the light passes through it.
Very good. Clap for Simeo. Air is transparent, and therefore it cannot block the path of light.
Light can pass through them. You can have multiple shadows. It all depends on the number of light sources. The more the number of lights, the more shadows you will have.
So is it true that we can have multiple shadows? Yes. Why? How do we have multiple shadows? How can an object have multiple shadows? Or why will an object have multiple shadows? Yes, Brian?
And there are more than one source of light.
Very good. When we have more than one source of light, can we see here? We have source 1, 2, and 3. More than one source of light, we have more than one shadow. Eh? So it's true an object can have multiple shadows depending on the number of sources of light that we have. Eh?
Oh, there goes Mr. Deer again. Hey! You got to see how Mr. Deer changes in size. There's a reason behind it.
Why do you think Mr. Deer will change in size? Somebody to predict? What could happen to cause the shadow of our Mr. Deer here to change in size? Yes, John?
The distance of the opaque object from the source of light.
Very good. The distance of the opaque object from the source of light. Let's see. Is it true?
When I move the lights away from my hand,
There. The light has moved away from the opaque. What has happened to the shadow? It has become smaller. Very good.
the shadow becomes smaller in size. And when
The light has moved closer to the opaque object. Can you see the change in the shadow now? Very good.
bring the light source near, the shadow becomes large. When you put the light source just over the object,
When the light source is above the object, anything special you can see about the shadow? What can you say about that shadow that is cast? Yes, James?
Shadow that informs is short.
Very good. Can we all see that? Clap for James. The shadow that is formed here is shorter, isn't it? Right? Let's see what happens if that source of light moves alongside the object.
get the shortest shadow. Whoa! Mr. Deer looks so small now.
There. The light source has moved adjacent to the opaque object in a different position. Can you see the effect on the shadow? What is the effect on the shadow? What is the effect on the shadow? Yes, Kihuyu. The shadow is bigger, or we can clearly see the shadow is elongated. Clap for Kihuyu. When the source of light moves in that direction, the shadow becomes elongated. So, from this video, I want us to proceed into explaining further how shadows vary. But before we go into that, we are saying that a shadow is formed when an opaque object stands in the path of light. You can see we have two images. The first image has been extracted from that video you've just seen. Shadows of the little boy, the tree, and our professor are cast on the ground as seen. They are blocking the sun rays from this direction, and therefore they are casting a shadow on the ground. Your teacher and a few of these students are casting a shadow on the ground. What is happening here is that the teacher and the students are the opaque objects, and therefore they are blocking the sun rays coming from this direction. And this region is what you are calling the shadow. So in totality, what can we define a shadow as? Somebody to read for us here. Yes, Grace.
A shadow is a region of partial or total darkness formed when an opaque object blocks the path of light.
Come up again.
A shadow is a region of partial or total darkness formed when an opaque object blocks the path of light.
Very good. Can you note that point down? That a shadow is a region of partial or total darkness formed when an opaque object blocks the path of light. A region of partial or total darkness formed when an opaque object blocks the path of light. Such materials like air and or clear water will not cast shadows. We've already said that they are transparent, and therefore they allow light to pass through them, and therefore their shadow cannot be cast on the ground. Shadows may also vary in size, as you've seen earlier on. And we're saying, looking at these two images, the teacher and the student here are of different size. Though their shadows I've noted down here is that this is an early morning an early morning shadow. This other shadow here, the teacher and the student, is a noontime shadow. Can you tell the difference? What is the difference in the early morning shadow and the noontime shadow we have on that screen? Yes, Mwangi. Speak up, speak up.
Shadow on the morning
Yes.
is elongated, and the shadow at the midnight is short.
Very good. The early morning shadow is elongated. Can we see that? The noontime shadow is much shorter. Why? Why do we have an elongated and a shorter noontime shadow? Yes, Hannah. The position of the source of light. And where is it? Directly overhead, above the objects. That's why we have a shorter shadow than the early morning shadow. The sun here is much lower in the sky, and therefore it will cast a much longer shadow because it is illuminating these objects at an angle. And therefore, what factors affect the type of the shadow formed? That's now when we want to do a demonstration to investigate the factors that affect the type of the shadow formed. So the apparatus for this experiment that we are going to conduct today will require some sources of light. These are our sources of light. One source of light, we've improvised the projector to be a source of light, and the other source of light. We shall use both sources to see, do they have any difference in the type of the shadow that is being formed. We will also use opaque objects. We have our opaque objects here that we shall use to see how the shadow formed varies depending on either a number of factors that we shall be looking at. We still have more opaque objects that we shall use at this point. And therefore, I will request the last two benches to come and stand behind this bench, and some to stand here. Move fast, move fast. That group stand up. So Samson and Benedict will guide us through this procedure. We are going to carry out three main procedures. Our first procedure, stand here, stand here. Our first procedure, we want to investigate how the size of the opaque object affects the type of the shadow formed. So, here we go. Bandit will be in charge of this opaque object, while Samson will be in charge of this other opaque object. Comparing the two opaque objects, Samson's opaque object and Benedict's opaque object. Which is the larger of the two? Benedict's opaque object is bigger than Samson's opaque object. And therefore, so I'll ask, sorry. Hold the opaque object, bend it. Samson, hold the opaque object. So I want Samson to place his opaque object in the path of light of our first source. Place it here. Push it slightly ahead, that side. What do we see on the board? Somebody? Kinyanjui, what can you see? A shadow of our opaque object being cast. Now, Bendit will bring her opaque object same distance from the source of light at that point. Very good. Can you see now the shadow of Bendit's opaque object? What is the difference in the two shadows that are cast by these two objects? Pair up and share. Write down the difference. You can see? No. You can discuss here. So. Yes. What is the difference? Shampton.
The larger opaque object
Yes.
has a larger shadow, and the small opaque object has a small shadow.
Very good. The larger opaque objects, we can see cast a much bigger shadow. The smaller opaque objects cast a smaller shadow. Right? Second procedure that I want us to look at, now using one of these opaque objects. So Bendit and Shampton and Samson can sit down. Kihuyu, or rather, Francis can. Now Francis shall use one opaque object. So I want Francis to move this opaque object. You watch keenly what happens to the size of the shadow. So at this point, note the size of the shadow of the opaque object. Now, I want Francis to move this opaque object closer to the source of light. Slowly, slowly. There. Stop. Is there any difference you can see? Yes. Move much closer. There. Very good. What difference is there between this shadow formed when this opaque object is closer to the source of light and when Francis moves the opaque object away from the source of light? What is the difference? Yes, Alice.
When the opaque object is smaller than the source of light, the shadow cast is big, but when the opaque object is far from the source of light, the shadow cast is small.
Very good. The shadow cast by the opaque object closer to the source of light is much bigger than further away from the source of light. Very good. Third step, if I bring in a second source of light, I'll use my second projector as the source of light. Bear with me. Now, of our second source, we have the first source and the second source. When they combine together, they form what we refer to as an extended source. So probably, Boogie, come. I want you to see what happens to this shadow as we vary the distance of the object from the source of light. So you will push it towards the source of light, slowly, there, further away from the source of light. Very good. Clap from Google. Now, when the object is closer to the source of light, we can still confirm that the shadow is much bigger, isn't it? When the object is further away from the source of light, the shadow becomes smaller. But there is something else that is different from when the source of light is one, like what you have there, right? 1 point source, look at the shadow that is formed. When you have one point source, we can see how the shadow changes at that point. Now, when we have two sources of light, what happens that you've seen on the shadow form? Yes, Grace.
When we use a point source, the shadow form only has one region, but when we use a extended source, there is two regions in the shadow form.
We have clearly seen, that is very good. Clap for Grace. The shadow formed by a point source has only one uniform region. The shadow formed by a point source has only one uniform region. However, when we have two sources of light, they play the role of an extended source. We can clearly see that we have a shadow that has two regions. There is this central region, which is much darker, and there is this outer region, which is much lighter. Are we together on that? So the central region is much darker than the outer region. What name do we call this central region? And what name do we call this outer region? Yes, Peter.
The region with total darkness.
Yes.
Is the Umbra.
The Umbra. So in other words, what is an Umbra? We are defining an Umbra as, we're writing that, we are defining an Umbra as a region of total darkness in a shadow. A region of total darkness in a shadow. A region of total darkness in a shadow. This other outer region that is partially dark, this outer region that is partially dark, we are calling it, yes, the penumbra. Very good. The penumbra is a region of a shadow that has partial darkness. It's a region of a shadow that has partial darkness. And therefore, from that simple demonstration, let us further see what we have learned today about the factors and how the shadow changes. From the first observation we made, when we have different sizes of the opaque objects, we can see clearly on this board that the shadow that is cast by a bigger object is much bigger than the shadow that is cast by a smaller object. The second observation we noted was the observation to do with the distance of the opaque object from the source of light. We can clearly see that when the opaque object is very far away from the source of light, the shadow cast is much smaller than when the opaque object is much closer to the source of light. And finally, the point source gives us a shadow that has uniform darkness. The shadow cast by a point source with a uniform darkness, we call it the umbra. So an umbra is simply a part of the shadow that has total darkness and or uniform darkness. Whereas an extended source, as you can see on the board, forms a shadow that has two regions. A region of partial darkness, can we see that? Yes. And a region of total darkness. This region of partial darkness, we call it the penumbra. The region of total darkness, we call it the Umbra. So we have the region of total darkness, Umbra, and the region of partial darkness, the penumbra. So what conclusion can we make from those three observations? What conclusion can we make from those three observations? Yes, Paul. Yes?
And it's not a
The bigger the opaque object, the bigger the shadow cast. We are writing that. The bigger the opaque object, the bigger the shadow cast, and the smaller the opaque object, the smaller the shadow cast. Conclusion number 2. Yes, Steven.
The closer the opaque object, the source of light, the bigger the size of the shadow form, and the far the opaque object from the source of light is much.
Very good. When the opaque object is far from the source, it casts a smaller shadow. When the opaque object is closer to the source, it casts a bigger shadow. And finally, what other conclusion can we make from these 3 observations that we have just seen? What other conclusion can we make? Yes, George.
When you are having a point source,
Yes.
the shadow casted is 1.
Very good.
When you have an extended source of light,
Yes.
it produces multiple shadows.
Very good. So George is telling us that when you have a point source, it produces 1 shadow. Maybe I may add and say 1 shadow of total darkness. When you have an extended source, we are producing a shadow that has 2 regions. A region of total darkness, which we refer to as, yes, George? The Umbra, very good. And another region of partial darkness that you have referred to as the penumbra. So those 3 conclusions that we've come up with are the factors that affect the type of the shadow formed. So 3 main factors, namely 1, Samson,
The size of the object.
the size of the opaque object. The bigger the opaque object, the bigger the shadow cast. The smaller the opaque object, the smaller the shadow cast. Second factor, yes, come here.
The distance of the opaque object from the source of light.
The distance of the opaque object from the source of light. A far object casts a smaller shadow than a nearer object to the source of light. And finally, the third factor, yes, Angulu? The nature and of the size of the source of light. Very good. We have the point source versus the extended. So those are the 3 main factors that affect the type of the shadow formed, as we can see on the board. So why learn this concept of shadows? This concept of shadow formation is applied in the next concept that we have been looking at, the phases of the moon and the formation of the eclipse. Now that we have learned how shadows are formed and what factors affect shadow formation, we shall dwell into the application part of this in our next lesson, phases of the moon and formation of the eclipse. Do we have any question up to that point? Yes, I. Yes? Very good question, Ivy. Ivy is asking that, now that you have looked at shadow formation, how does this concept of shadow formation prove that indeed light travels in a straight line? Who can attempt that question? How does the concept of shadow formation prove that light travels in a straight line? Yes, Onyoyi.
When the object is straight, is put in place where the light is passing.
Yes.
If light doesn't pass a straight line, it will come and cover the path that is gone.
Very good. Wanyeke, you has come up with a very good point. An object placed in the path of light will cast a shadow. If light was not traveling in a straight line, it will mean the light will curve around the object and there will be no there will be no shadow. Ivy, got the answer to that? So if light was not traveling on a straight line, there will be no shadows formed because the light will just come around the object. Very good question. Any other question? Yes, Hannah?
Okay. You have concluded that light travels in a straight line.
Yes.
But why do you refer to as refraction as the bending of light?
Wow, that's a very good question. Hannah is asking, why do we refer to bending of light as a refraction? And you have said light does not bend. The concept Hannah is talking about, refraction, is when light passes from one transparent medium into the other. For example, when light passes from air into glass, when you put your hand in water and you observe your hand above the water and inside the water, you are likely to see your hand having a slight bend, isn't it? That is refraction. In that case, light bends when it passes from one transparent medium to another transparent medium. Later on we shall learn about that in terms of refraction of light in Form 3. But for now, light traveling through one medium travels in a straight line. But when it passes from one medium to the other, it can bend, as the case of Hannah is attributing to. Very good. And therefore, to come to the end of this lesson, there is an assignment that you are going to do. I have given the assignment in these handouts, in your groups. The assignment is at the back of the handout there. The assignment is at the back of this handout in your respective groups. But the assignment will only deal with, you do further research on the phases of the moon and formation of the eclipse, then answer those questions in the phases of the moon and eclipse formation. To help you do that assignment, we have those resources. We have your physics textbooks, KLB books, and you can also have given you a site there. You can go on YouTube to find out more about this topic of shadow formation. You can also go to my YouTube channel. I will upload, or rather I have uploaded this knowledge on shadow formation and formation of eclipse and phases of the moon for your further reading so that you can be able to complete that task ahead. Thank you very much. We've come to the end of our today's lesson. And if there are no further questions, we may proceed to our next class. Have a good afternoon.